let's talk about these. Sometimes, always, never. What did you ultimately decide for number one?
Sand.
What did you figure out? S-A-N?
Sand.
Sand?
Yep.
So you thought the top, or let's go with the middle one. Why is the middle one always true? I agree with you. It's always true. Why?
It says it's approaching.
Yeah. What is a horizontal asymptote? The limit as x approaches infinity. So end behavior asymptotes. How do we behave at the ends? So number two is clearly always. Now, why is number three never? Because if you're approaching infinity as you approach three, then you don't have a zero there. What do you have?
Asymptote.
An asymptote, yeah. So that one's never true. That makes number one sometimes true. Now, number one says, if 3 makes the denominator 0, then there's a vertical asymptote at 3. Why is that only sometimes true? Because it could be a hole. That's exactly right. It could be a hole. Right? Yep, perfect. All right, did you get number 2? What did you get for number 2?
ASN.
What?
ASN.
That's what I got for confidence.
You got A,
ASN.
ASN.
I got
I don't think that's right, buddy. I'm off.
I
I
got
got
SN.
AS.
I got SNA.
Everyone has different. It's
Everyone
not.
has different answers. So let me tell you why I think, I like to do the nevers first. Why do I think statement 2 is a never? If h of 2 is 0, then there's a 0 at 2. Where's h? H is my denominator. If the denominator is 0, you're either going to have a hole or a vertical asymptote, right? You're not going to have anything else. So do you understand why number 2 is never? That cannot be. If your denominator is 0, you either cancel it out and have a hole there, or it stays and you have an asymptote there. You're not going to have an intercept there. So that's a never. So why do I think number 3 is always? Well, G is the numerator. So if the numerator is 0 and the denominator is not 0, then there has to be a 0 there. Right? What does it mean to be a 0? When you look at a function like, what does it mean to be a 0? It means you plug something in and get 0. There's only one number that's going to make that 0, and the number is 2. The only way that won't be a 0 is if you also have one of those in the denominator. Then you wouldn't have a 0, you'd have a hole. But they tell me in the problem, the numerator gives me 0, but the denominator doesn't. So therefore, it has to be an intercept. It has to be a root. That leaves sometimes for the numerator. If the numerator is 0, then do I have to have a 0? Well, I already answered that. If I put 2 in, would my numerator be 0? Yeah, but unfortunately, so wouldn't be my denominator. So I'm not going to have a 0 there. I'm going to have a hole. So I could have a hole. I could have a 0. I could. But I could also have a hole depending on what's going on with the denominator. Okay, got it? Got to register all this in your head. All right, anybody get number 3? What did you guess for number 3? Declan?
All I like is A for the top.
A for the top, I agree. I agree, A for the top. K is, if we know that function K, whatever it is, it has a vertical a vertical asymptote at -2. And it has a horizontal asymptote also at -2. That's the original picture. Now, what are we doing to the picture here? We're multiplying it by -2, adding a 3 to the x, and adding a 7 to the n. Okay? Now, let's think about this for a second. Let's talk about the vertical asymptote. What does multiplying the vertical asymptote by -2 do? Nothing. Because what does this multiplier do? Turns you upside down and doubles your height. Well, if you're a vertical line, you don't have height and you can't be turned upside down. So that's not gonna impact it. Is that gonna impact the vertical asymptote? Yeah, because it's gonna move the whole picture 3 units to the left. So if you pick this guy up and move him 3 units to the left, where's he gonna be? -5. Does adding 7 to that change a vertical asymptote? No. So that is always true. If you make these transformations, your x's are moving 3 to the left, including the asymptote. So it will be at -5. Now, let's talk about the horizontal asymptote. Here it is, -2. Is that gonna change it? That, absolutely it's gonna change it, because that takes your y's and times them by -2. So where's this asymptote now? At +4? Will that change your horizontal asymptote? No, but will that? Yep, move it up 7, so it was at 4, now it's gonna be at y equals 11, not at y equals 5. So that's a never. That means the last one has to be sometimes. Well, that makes sense, doesn't it? Do I know anything about the zeros of this thing? Could they end up at -2? Now be careful, remember that got moved. In the new problem, that vertical asymptote's now at -5. So could I have a vertical asymptote at -5, a horizontal asymptote at 11, and a 0 at -2? Could that work? Could, I have no idea. Could, maybe not, maybe so. All right, how about 4? Do we have any luck with 4? What did we get there? You got what? Never, always, sometimes. I actually got always, never, sometimes. So let's see. Let's see, what's your logic with that first one? Or is that with number 1 yet? So the new function is going to do what? What am I doing? Turning it upside down, moving it h to the left, and sideways of it, yeah, and then up 4. So where is the original horizontal asymptote? In the original picture, it's at -3. Right? Now, which of these numbers are going to impact a horizontal asymptote?
+4.
That's going to become now +3, and that's going to move it up 4. So is it going to have a horizontal asymptote at 7? It sure is. That's where it's going to end up. It's going to end up at 7, so that's always true. Now, where is the vertical asymptote in the original picture? In the original picture, the vertical asymptote is at -1. Yeah.
Because it'd be negative h plus 1.
Yeah. So
Or negative h minus 1, right?
this guy right here is being moved h, right? If that, look, think of that as x plus 3. Wouldn't that move you to the left 3? If it's x minus 3, it's moving you to the right 3. That number is moving this asymptote. So is it gonna ever end up at plane h? No, it's gonna be negative 1 plus h or minus h, depending on which way you're going, right?
Can h equal 0?
Oh,
So I put sometimes thinking h could equal 0, meaning
all it says is h is a constant.
Okay, Cal.
Well, but then it would still get negative 1, wouldn't it? Because negative 1 plus 0.
Yeah, but if h is 0, then you're just having the original p of x. So that wouldn't put the asymptote at 0. That would leave it at negative 1. Yeah, so it's still an error. Every h is an error. So always for the first one, never for the second one. Again, could we have a 0 at, or could we have a 0 at 0? Yeah, if x is, or I mean, excuse me, if h has a certain value, then I could end up with a 0. All right, backside. Anybody do any of these? Which of the following are correct? I haven't done these yet, but I did them earlier. Let me see if I know. Is it just one
don't mess with
correct, or are
Texas.
there more than
Big
one
it.
correct?
You
for
don't
each
mess
of
with
them?
Texas, you don't pay taxes.
Anybody know?
86.
There's only one correct for each one. Anybody find the correct one? A. Why is A correct? Because when you cancel, you get a vertical asymptote at 3 and a hole at negative 2. Would you agree with that? All right, number 2, you said the answer was C. Limit as we approach 2 from the left is positive infinity. Yep, you can tell that from your picture. So C is correct for number 2. Anybody make it to 3? Which one? Ooh, I did not say D. I said A. Now, if we multiply out our numerator, what would be the leading term? Negative 2x cubed. And if we did the same thing on the bottom, it would be 1x cubed. So my horizontal asymptote will be negative 2x cubed over x cubed, negative 2. Y equals negative 2. You okay? Now 4 is what we were kind of just talking about. What is happening in the problem? Keep track of what are the changes that you're making. Negative 4p x plus 1 plus 5. So what are we doing? We're turning it, basically we're multiplying the y's by negative 4, right? We're turning it upside down and making it 4 times as big. What's this doing?
Moving it to the left 1.
Left 1. And what's that doing? Up 5. Okay? So what's the original? The original was, we have a vertical at 3 and a horizontal at 2. So what's happening to those guys? First of all, your vertical asymptote, this isn't changing it and that's not changing it. So your vertical asymptote's going left 1, it's gonna be at 2. Do I have any of those? Yep, my answer is either A or B. Let's look at our vertical. I mean our horizontal. What's happening to it? Well, it starts out at 2. This is gonna put it at negative 8. And that's gonna put it at negative 3. Do A and B have that option? Yep, A. A. And 5 quickly is one of our little inequalities. X minus 2 minus plus 1. And minus 4 plus 1. And I want that to be bigger than or equal to 0. So here's my number line. Negative 1 has to be included as a dot, but an open dot. 4 is an open dot, and 2 can be a closed dot. Would you agree with that? So if I put in negative 2, I'm going to get negative over negative, which works. If I put in 0, I also get negative over negative. That works. If I put in 3, I get positive over negative. That does not. And if I put in 5, it works. So which of those is that? Negative infinity to negative 1. Negative 1 to 2. And for, I think it's D. Now, let me tell you a little something about these exercises called 5 for 5. Did you see that's what it's called? Okay, you know the AP score, math stand is 5. So the idea is, if you can do all 5 of these problems, you're on your way to a 5. Because there's a really simple problem, there's an easy problem, there's a medium problem, there's a sort of tough problem, and then there's a tough problem. If you can get them all, then you're right on target. If any of that confuses you, we have work to do, because we are all going to get 5s. All right, you got an assignment due. I think this is the end of the period. That could be wrong. I could be wrong.
35.
35. All right, let's take a quick look at your, somebody had a question about a homework problem. The homework is due on tomorrow. Let's take a look at, remember yesterday, we were doing those problems where we had to figure things out. So quickly, let's see if we can do 3A in the homework. Let's see if we can do 3A together. Now, let's look at what we know. If we are approaching 1 and getting negative 4, did I do this one already? No? Okay. If I'm approaching 1 and getting negative 4, then doesn't that have to be a whole? Right? I'm in the homework, number 3A. And if I'm approaching 4 and going to infinity, then doesn't that need to be an asymptote? That's what's happening. Is everybody okay with that? The given? So now, what are going to be the bones of the equation? What is going to put a hole at 1? What am I going to have? X minus 1 and x minus 1, right? What is going to put an asymptote at 4? X minus 4. Now, those are givens, right? Those are givens. Yesterday, didn't we have a problem? We did, because I messed it up. We had a problem where the end behavior was the same on both sides. How did we end up fixing that yesterday? Because normally, one side's going to go down and one side's going to go up. Who remembers what we did to our problem? We squared the asymptote, right? But they're both going down. So now I got to figure out that's happening. Plus, I got to be able to plug in 1 and get -4, right? So I got some work to do yet, but are you with me so far? Okay, so I want them both, well, let's work on getting that -4. If I cancel those out, right now, this is what I have. Would everyone agree with that? Okay, so, I need to end up with -4. What do I get right now? If I plug in 1, I get 1/9, right? So how about if I put a -36 up here? One step at a time. If I put in 1, will that give me -4? Okay, so let's see what happens if I put in 2. If my equation is right, when I put in 2, I'm gonna get something less than -4. So let's put in 2. I put in 2, what do I get? 2 minus 4, I get 4. I get -9. Is that good? Alright, let's try over here. What if I put in 5? If I put in 5, I get -36. What if I put in 6? This is -36. If I put in 6, I get -9. Is that what I want to have happen? So there is a possible, well, put that back in, you gotta put these back in. But there is a possible equation. Alright? Now, I'm gonna let you do the second one on your own. You're gonna have to struggle with that. But what do you do? First start by putting into the equation what you know has to be there. Then start messing with it, one step at a time, and it'll all come together.
I'll run out and put back in.
Alright, have a great day.
Oh, so you'll do it before.
One more period and you're done.